So we have these cables, because I hate being a talking head. So we've got these cables with mics, so we don't have wireless, so we're kind of chained to being talking heads. But today, when I wrote out this abstract and planned to give this talk, I didn't realize we had a new hire at SUSE who's an actual implementer consultant for big data. So I said, come on up and throw in your 2 cents. And we decided that last night, before we had drinks. So just want to be clear about that. So Gaby Beitler is a sales engineer. He's based in Philadelphia.
Correct.
And my name is Peter Linnell. I'm a sales engineer. I've been at SUSE for 4 years. Before I came to SUSE, I worked for Cloudera, and I'm part of an Apache software project called Apache Big Data. I've been involved in open source for 15 years, SUSE user for 15 years, and Gaby's got an extensive background in big data as well, implementing, helping customers solve real-world problems. So that's when I put up the sign, I put my emails up. They're like, what's this all about? Well, I'm an Apache guy, and I'm also an OpenSUSE guy, which is something that I think is really cool about SUSE is I came from the community and came on board, and the ambiance behind and in front of the firewall is no different. So before we talk about big data, it's always good, if you've been in technology for any amount of time, to have a slightly cynical eye on all kinds of buzzwords and things like that. So I always like Dilbert's take on big data. And it's so true. So the first thing you want to talk about when I always like to talk about big data is the hype cycle, because you have the technology trigger, the peak of inflated expectation, the trough of disillusionment, the slope of enlightenment, and then the plateau of productivity. It sounds almost romantic, like psychology. So big data is kind of up there right now, and it's sliding down that trough of disillusionment, because what people have found out is, like Dilbert said, it's hard. It's not an easy thing to solve. And so when I do these talks, my aim is to give you folks a little bit of education on what big data is, understand the terminology from a high level, because there's jargon, which is specific to big data and IoT. Explain to you the complexities of choice that you face, and then some kind of a mental approach to tackling a problem and how you would work with the customers or in your own company to solve these sorts of things. And I'm trying to actually silence my phones, because dollars to donuts, my daughter will call. Just, it happens. I want to talk to Daddy. So, done. In any case, the next thing we want to look at is see how Linux is the foundation for big data. When we talk about cloud, it almost invariably is we're talking about Linux. And when we talk about big data, it's almost invariably about Linux. And why? Scale, low cost, you can run it on off-the-shelf hardware, there's no lock-in, and competition. So why is that picture relevant? Well, there's the SUSE guy next to a guy from WANDisco, who's next to a guy from Microsoft, who's next to a guy from Hortonworks, and the two guys in the corner, one's from Pivotal, and the other guy's from Cloudera, and he's from a third-party company that uses big data internally. Some of those guys are my old Cloudera team. And when I was at Cloudera, I was part of what we call the kitchen team. We actually built the stack. So that's one of the really key things about Linux is the foundation of big data. The challenge of big data from the high level is its complexity. Vendor selection, understanding the use cases, developing the workloads, and having a sense of internal capabilities within your own company. And when I talk about vendor selection, this is a true story. One of our good customers, they're a truck manufacturer, they've got this idea of a connected truck, a smart truck, because that saves customers money, it increases their value add, it makes them sticky because the customer wants data coming from the company and things like that. And as we were talking to them about other things, they were implementing SAP HANA, and then I said, well, don't forget that Hadoop is part of that equation. And they're like, what do you mean? I'm like, there's a use case for SAP HANA with Hadoop side by side. So I said, here's what I'd like to do. I said, we're going to come in. I'm not going to do any slide decks or talks or anything like that. We're going to do a whiteboard session. They said, we've had every big data vendor coming through here, and now we're confused. And I said, well, fine. So we had a 2-hour whiteboard session. And they were like, they're trying to think about vendor pick. I'm like, no. You're starting we're going to go way, way, way back. Tell us what you're trying to do. So then we went through a whiteboard session, and we were able to narrow out probably 50% of the possibilities they were contemplating. So this is to give you a sense of the complexity. This eye chart, sorry for it, that's just the database vendors from 3 years ago, and it hasn't gotten any less complex, and also some of these companies have either been bought or disappeared. And so this shows, like, when it shows relations in different parts, it shows technologies which have similarities, and then the further away, the less they have in common. And I think the thing to understand here is you need to understand that somebody will come to you and say, oh, use X. Well, no. What you need to do is figure out your use case workload. Then you say which satisfies those things. Because you hear great things about in a company, things like Accumulo or Cassandra or MongoDB. They all have great feature sets, but they also have functionality that only works within or resides within certain workflows. And don't hesitate to jump in.
Yeah, so the other thing that I would step back and ask, what is the question that you're asking of big data? Because with big data, your result sets are going to be not an answer 42. It's going to be some variation of X, Y, and Z correlate to A, B, and C. And it's going to be a subset of that data. So take the question to determine the data that you need to answer the question, to then go and look at the tools that help you answer the question.
Exactly. And one of the other things that you'll find when you start tackling these big data analytic stacks and problems is, number one, you're going to find some surprises in the data. You're going to find things you didn't expect, whether it be a behavior pattern of a customer, things like that. Sometimes you also have to test how you're asking the question, because that, like statistical polling, like today for elections, how you phrase a question in an election poll has a great amount of bearing on the results. So pollsters actually ask the question in several different ways, and they'll find they'll get several different results. But then they'll test against the actual vote to figure out how they asked the question affected the actual real-world results. Does it make sense? And by the way, usually when I give talks, I hate being chained to a wire. I usually have swag. So today we have to do virtual swag. Usually I get up and talk. I go in front of a group and I put a big pile of hats and the swag and I say, sorry, you're not getting that. You have to get that by asking questions. So I love questions. I love comments and things like that, because it kind of feels, I always never say I'm going to give a talk. I want to start a discussion. So that's the other eye chart that shows you the complexity of the big data vendor landscape, and that's a much newer one. But you can see here, you'll see it on the PDF. All of these different technologies have a place. You don't need all of them, but if you look at it, things like data sources and APIs, IoT, location data, which one of these you pick for data affects what you buy up on top. So when we talk about big data, it's really, really important to have an understanding of the jargon list. When people talk about Hadoop, they can get confused. Hadoop, as I call it, core Hadoop is the data operating system. It's two parts, or actually it's one plus A or B. Number one, it's the engine called MapReduce, which does the calculations. And the other part's HDFS, or sorry, I messed the order up. It's HDFS, which is the file system, which actually has a lot of commonalities with SUSE Enterprise Storage because it actually lays out the cluster with 3 replicas, and it's smart to spread the data far enough in the cluster so you have redundancy, but close enough so you have good performance. So that's a tunable, but that's where, when we talk about why you're not going to want to put Hadoop or big data in a cloud, Hadoop is cluster aware. It's smart enough to know that it's in rack A or rack B or rack C, if you enable it. Apache Hadoop is that big ecosystem. When I showed you that slide before, a lot of those components that are the basis of those commercial offerings come from Apache Hadoop ecosystem. NoSQL, new SQL, it's a way of storing data mostly in memory for quickly searching for data. Column store versus complex tables, things like that. And we in the big data world, we talk about data temperature. Cold data, it's stored nearby. Maybe that's a tape archive. That may be redundant offsite, something like that. Hot and fast, that's the in-memory of intelligent caching, like grid game. SAP, you could say, is hot fast. Live data means it's accessible to big data tools. And dead data is offline data. And to the big data practitioner's mindset, it's useless. It's the store everything, throw away nothing mentality of big data. So that creates what the practitioners call data lakes. And the term ACID, as it relates to databases, atomicity, consistency, isolation, and durability. And that has to do with how you can have a database which is a coherent and uncorrupted source of truth.
Can I ask a question of the group here? How many actually have big data implementations that they're responsible for managing today? Kind of, sort of, right?
Or you're working with customers that are looking at it. That's more the case.
Okay.
Then that's good in some respects because this isn't something that you can learn about, and when that lands in your lap, you've got some basis to say, hey, I think I got an idea how to grasp this. And I have an idea of how to ask the right questions.
So on that topic, if I can for
Go
a
ahead.
second.
No, go ahead.
On the grasping, the way that I like to move into new technologies is I have years of experience in the industry, and then I take the new technology and I slot it to something that's in the past that I've had experience with. So coming from an HPC background, right, I came to a lot of environments where people were doing Hadoop, and they brought in a DBA, they brought in a sysadmin, and they brought in a BI analyst. And the project went down the toilet. And then I came to other sites where they brought in the HPC architect, they brought in a data scientist, and they brought in a sysadmin that knew Java, right? And those projects were successful. The reason that the projects differed so much is because the DBA is going to look at the problem, and you're going to talk about this later, in a relational database concept. Right?
Yes.
HPC is going to talk to the concept more like what big data is. It's distributed computing over a large number of nodes to get faster and faster processing and scalability. Right?
Yes.
So having the right people in the room when you're laying out that design really pays off on the back end of implementation.
And I also came from an HPC background. Before I came to SUSE and Cloudera, I worked for a research lab in France, which was a supercomputing HPC research lab. And we did a project called ExtremeOS, which was about enabling large grids, academic computing grids, to run POSIX binaries. So you could launch a job in Italy, and it was smart enough to save the data in Berlin. Things like that. But that's what we call labware. We did have one good part of it actually get commercialized, and it's called ExtremeFS. And it's a lot like Ceph, an internet file system. So these are some challenges. Existing data workflows are siloed for many different reasons, because the data may reside inside of silos inside a company or in an agency. The formats and the proprietary applications can play a part in that. Of course, you've got sensitive data concerns. You've got regulatory blockages that say you can't do that. You've got budget constraints and planning lead times. And the challenge is, especially when you're doing budgeting and planning lead times, this technology is changing so rapidly. That's a real fundamental challenge. For example, IBM is talking about this technology called Spark, which is in-memory analytics. And I can tell you that came out of nowhere inside of 2 years. When I was I lived in Silicon Valley at the time. I'd left Cloudera at that point I was 2 years out of Cloudera, and I was at SUSE for a couple of years. And one of my fellow ex-Cloudera teammates, he said, "What do you think of this Spark stuff?" And I looked at it, and went and looked at it, and it was coming out of what's called the Berkeley AMP Lab. And I said, "Well, if they do it right, this is going to be crusher." And he said, "Yeah, I thought the same thing." And so now you have IBM investing 1,500 developers to work on Spark, and that's 2 years ago. I mean, if you had asked me, if I had said to you, one of the cool technologies right now is called Spark, if you asked that question 2 years ago, nobody would have an answer for it. So that's one of the challenges in this environment, is that technology is also rapidly changing. Some other ones. I hate to paint such a dour picture, but I want to give you folks a really realistic picture of what you're facing, what you might face, and also, but to have some tools to be able to tackle these things. Big data challenges. Data scrubbing is the step that never gets mentioned, but it can be indeed one of the biggest challenges in terms of lead times and planning. There's a major healthcare company that wanted to import 56 petabytes of medical data into a Hadoop system and ingest it and use it for analytics and all kinds of fun stuff. The problem is that it took them 4 months to anonymize the data. They never planned for that step. It completely threw a monkey wrench, and they had to hire extra guys from an outside big data consultancy to come on board. They basically hired 7 guys for 4 months to just help them get through this data scrubbing phase. Big data likes memory. SUSE is an IBM mainframe mainstay. Big data is definitely part, or a mainframe can be definitely part of a big data solution, but it likes memory, and memory is expensive on a mainframe. Jobs can run longer than some mainframes, batch jobs, and one of the things that big data often you have to think about is when you're getting into big data, you also have to think about HPC, high performance computing, because the way that jobs run typically in high performance computing clusters is there's a scheduler, and then you'll run a simulation, and you get your results. And you run Hadoop the same way. The thing is, some of these jobs can be quite long, and you need to think about optimizing queries to save time. And that's the job of the data scientist. How do I figure out to optimize the queries on the data I'm making? And this is a really, really fundamental thing to think about, to understand why the way you set up Hadoop and big data solutions is kind of different from traditional databases. Traditional applications is it turns the node of the processing power completely on its head. We are in traditional computing, if you want to say, you have this very fast, very powerful server with this very fast, very powerful, expensive storage array or a SAN or what have you. So you take the data and you pull it across and you massage the data on a very powerful server, and then you spit the results out. The way that Hadoop was able to scale was it sent the computing power out where the storage is. So you'll find that Hadoop clusters tend to be rather powerful systems, even if that's just where the data is sitting. Unlike, say, a Ceph cluster where you might have 10 disks and maybe 1 or 2 CPUs, you could warrant having very powerful 128 gig, 256 gig data nodes for your Hadoop cluster. And in fact, I worked with HPE a year and a half back. We did a reference architecture for Hortonworks running on SUSE Enterprise Linux on an HPE converged systems. And I was stunned when we started. I immediately assumed, okay, we'll use 64 meg systems, 64 gig systems. And once we actually started playing with the numbers, we found we got a better performance value, money value, by going to 128 and 256 gig systems. bigger systems, but fewer of them, which kind of really surprised me. Big data does have some main advantages on mainframes. They work like mainframes. They're batch-oriented. The big data platform is open source. There's no vendor lock-in. We'll talk about Apache Big Top. And if you're a mainframe shop, it gives you the ability to give new and innovative services for end users, and it helps with better informed decision making. Because at the end of the day, what big data is about is intelligence. You're trying to get derived actionable intelligence. You just don't want data, you don't want facts, you want intelligence that you can act upon. That's the real key. So, some examples of big data volumes. Scientific measurements. Hadron's a perfect example of it, and all that data resides on Ceph, which is the basis of SUSE Enterprise Storage. There are over 100 petabytes of data. The data that comes out of that Hadron Collider goes through a filter that immediately throws 70% of the data away, because they can't store that much. So if you can imagine, you're talking exabytes of data, raw data coming out of that collider. They have to filter it before they can actually store it and then analyze it. Financial data like stock information, medical data, genomic databases, really key application. Things like index web social media content, that's where you get what we call sentiment analysis. How do you figure out what your customers are thinking about my company? Environmental records, weather. There's a large retail store that one of the things they used big data for was for optimizing their inventory. So one of the questions they asked was, how do we sell umbrellas? And they started using historical data from weather to analyze when were the best days to sell umbrellas. So they used that as part of the calculus for their inventory. That's just one small application. Web application, logs of all kinds, and there's a lot of good, very mature tools to analyze all kinds of logs of different kinds. So the main use cases, what are we really after? We're after transparency. We're trying to figure out what's going on in our business operations. It could be it could be a way of curing manufacturing defects. A car company, for example, one of the things they used, they dumped all their warranty information for the prior 18 months into a big data solution. It was Hadoop. And one of the things they started doing was trying to correlate warranty issues that would correlate to other warranty issues. So for example, if what they discovered, in fact, was there was some correlation. So if component A failed, they found a correlation that a certain percentage of the time, component B would fail. So they changed the service recommendations based on this so that when the techs got this car coming in under a warranty claim, they'd say, oh, okay, fix this, and if the diagnosis is component A, also examine component B and do these tests, because that avoided a return for the car company. And that has a big impact on their GE Power scores, and it's expensive to the car companies for doing return warranty visits, and it ticks off the customer. So individualization in real time, perfect examples are stuff that pops up on Amazon and eBay. That is big data. That's a really awesome example of big data at work. Amazon does lots of analytics, so that's what is the thing that when you buy a book comes up with recommendations. They figured out correlations. If buyer A buys this book, then there's a probability of X that they will buy book B, C, D, or E. That's why those recommended titles come up. Intelligent process control and automation. Here's a good example. There's an oil company up in Canada. They have a $90 million SAP implementation with SAP HANA. And it's so smart, it analyzes worldwide pricing for fuel and oil all over the world in real time, near real time. And it uses that analytics to decide to turn a tap. One way it goes to Western Canada, gets shipped to Asia because there's a better price for them in Asia. Or no, the trend goes a certain way, turns the valve, puts it on a rail car, goes to the US to get refined. That's intelligent process control. It took a $90 million solution to it, but what's the return on that? When you're talking about millions of barrels of oil, you're talking hundreds of millions of dollars in price gains. Innovative, data-driven business models. Well, Amazon wouldn't have happened without this whole data-driven business model. eBay and things like that. That's all about big data.
The other business side, which I don't know if anybody here heard about, 8 months ago, IBM bought parts of the Weather Channel.
Yeah.
Did anybody hear this? Okay, do you know which part they left behind? The media company, right? What they wanted was the Weather Channel's data, right? And their analysis capability to determine when storms are going to happen. What's the impact going to be? Why? Because through Watson, they can do a lot of analysis and help companies determine if weather's going to affect their business. That was their acquisition.
Yep.
They didn't care about the cameras.
Yep. That's a true story. And in fact, I met a Weather Channel person that got brought over from the Weather Channel to IBM. And it was pretty interesting to understand that. So, scale of data, terabytes, petabytes, exabytes. I don't think anybody here is probably going to face exabytes like the Hadron Collider, or you wouldn't be here because you've already graduated big data. How complex is the data? What kind of data is it? Transactional and non-transactional is very, very important. Data integrity required. Sometimes you can be a little, you can actually store like stream data and data that comes from various sources like weather, say it's agricultural data, it could be traffic data, it could be things that come from environmental or atmospheric reports. Things like that, they don't have to have 100% accuracy. Because a lot of times in the case of what they're trying to do, they're not just looking for, we're not looking for a specific hard number, we're looking for trends. That's the real value. Usage patterns, the performance, real time, short delays or long delays. Real time can be done, or short delays or long delays, because it may be different questions you're asking. You can tolerate long delays if you're trying to analyze lots of historical data. That's one of the places you can tolerate a long delay. So, but I want something real time. I want HANA. If you bought SAP, anybody here has bought anybody here have an SAP HANA system in their company, in-house? It's an expensive machine, isn't it? And it scales to the very largest x86 platforms in the world. But that's because you're after real time. So when you look at usage and performance, if you go from real time to short delays to long delays, your costs have gone down. And going in the other direction, your costs are going to go up. And sometimes it's a combination of several questions of the above. So Hadoop versus traditional, what we call SQL, basically relational database management systems. You don't have to put a predefined schema. You just dump the stuff in. Just take, it's like, I always liken it in a visual analogy. You take a funnel and dump the data of word processing documents and PDFs and video and audio and Twitter feeds. That all can reside in that same file system without any problem at all. It's not a challenge. You don't have to figure the data structure out first. It's flexible and agile. Of course, you've got schema defined. You've got data transformations happening. It's fast reading. You've got standards governance. The real innovation is the ability to explore raw data because you haven't transformed it. So when to pick Hadoop versus a relational database? The way I liken Hadoop versus, or big data versus, say, a traditional database is, I always liken a database to a Ferrari. It can take a little tiny, you can take a small suitcase of stuff, put it in the car, and transport it very quickly. Hadoop is the big dump truck that you can put lots and lots of stuff in. It won't move as fast, but you can put lots and lots of stuff in it. So it's the dump truck versus Ferrari analogy. So some of the strengths of Apache Hadoop, and I speak of Apache Hadoop in the greater ecosystem. You have the capacity to use huge data volumes. The biggest cluster that I know of publicly is one that Yahoo had with 4,500 nodes on it. So those are large clusters, and those are very dense chassis with 10 disks, 15, 20 disks per chassis. The ability for unstructured data, you don't have to transform it, it's reliable. HDFS is a very, very fault-tolerant, very reliable, scalable file system. It's the lowest cost, it's open source, and it batch processes. So you can control which jobs and which questions you think are most important. Some of the weaknesses, and I have to be candid about it. It's not very efficient at small sizes. Real time for Hadoop itself is challenging. Spark helps that. It's a work in progress. It requires skilled engineers and operations. Now, I was there in the early days of Cloudera, and Cloudera was lucky. As a small startup, they had some very large customers buy in early. So a 70-man, 5-man startup, when I arrived, we already signed to eBay, and we landed Apple not long after, and we had Nokia and BlackBerry as customers. We're a 75-man startup. Why was it? Because these companies saw that strategically the value they could derive from big data was really, really important for them. So not only did they engage Cloudera early in, they went out and hired a lot of talent that they had skilled engineers with the help of the Cloudera folks to get their big data stuff working. It's less mature than SQL, which has been around, what, 40 years, something like that. And weakly defined user roles and data access, work in progress, and I give Intel a lot of credit. They've invested a lot of development around user roles, ACLs, things like that. They started a project called Apache Sentry, which is now part of Cloudera's Hadoop stack, and pretty much everybody's bought into that. What about all this NoSQL, new SQL stuff? It can be an effective replacement or supplement for traditional proprietary databases. One of the really great use cases for MongoDB is analyzing PDFs. You get a lot of PDFs, that's one of the best places to toss it and analyze it for keywords. Accumulo, which is a project that came from the NSA, that feature set is that it has very, very strong controls around the data. You can set up access control lists down to the cell level. And Cassandra is really great for things like shopping recommendations and all that, and it's scalable. And the Cassandra folks have done a really good job of making it a mature, robust, enterprise, digestible application database, but not in the sense of like Oracle or DB2, but they've done a good job with that. They solve different problems, and they have different strengths and weaknesses to evaluate. Now, I would not use Mongo to be doing the kinds of things I do with Cassandra, and vice versa. So that's the kind of thing that's the challenging part of understanding big data vendors and solutions, is they definitely have strengths and advantages and solving different problems.
So the way that I would relate it, since we're in a Linux environment and in an open source environment, you could use SCP or you could use FTP, right? That's fine. You could use SFTP too, right? But what are you trying to get to, and what data you're trying to move over, and what you're going through to get there is going to make a difference which tools you're going to use to do that. And that's the same thing with MongoDB, Accumulo, and Cassandra.
Yep, that's a very good simple analogy. Yeah. So Linux challenges, scalability. We're hitting the limit of physics with current technology. And why do I mention physics? Because that IBM mainframe out there, out in the technology showcase, that's the engines, the CPU engines that run a mainframe, run at 5.56 gigahertz. And the last 2 generations of mainframes have had exactly that speed, because IBM physicists cannot make the chip run any faster because they can't cool it any faster or the chips blow up. So we've hit the limit of physics in a CPU that can run at 5.56 gigahertz reliably. Sure, you can overcharge it for a little while, but your mainframe you want to run for years. So we've hit that limit right there with CPU technology. And in fact, what you find in many supercomputing clusters these days, if you look at the actual specs, I had the really good luck chance to go out to see a supercomputer from NASA called Pleiades. In any big supercomputing environment, they have a name. And what you find is that's an SGI cluster that merely had 11,000 nodes and now has been upgraded to a mere 14,000 node cluster. And when you see the scale of these things, they're amazing. The pipe, the conduit for the electricity going into the building is a sewer pipe like that big. And the cooling and the numbers are staggering. But what you find also is, what are those CPU speeds running at? They're very, very conservatively tuned, most of the time under 2.5 gigahertz, rarely above 3 gigahertz. And we know a lot of Intel chipsets can run at 3, 3.5 easily. Some of them run at 3.8, some of the gaming chips. So why is that? It's a compromise with electricity costs and power and cooling, but also for reliability. Because when you've got 11,000 nodes and they're multi-core systems, you've got 100,000 CPUs, you've got how many thousands of disks, you know they're going to fail. So you build in some headroom because of the challenges of physics and cooling and heat as a way to enhance your durability. So think about fault tolerance. We now have live kernel patching, which is awesome. Thank you, SUSE Labs and Wojtek. The future is going to bring us exascale challenges. Okay, we can run clusters reliably in the 10 to 15,000 node size. But think about when you're trying to run a cluster with 100,000 nodes in it and make it reliable. What you need to do is start to build fault tolerance into the OS itself. Now we're getting some of that. We don't have all of it. Java scalability. Now it was really fun. It was funny. I had a chance to talk with an Intel Hadoop engineer before they gave up doing their own Hadoop distribution. And he said, yeah, we did some tests at Intel. We're trying to figure out how to scale a Java virtual machine running with 1 terabyte of RAM in it. And he said the challenge we found is that because most of the Hadoop stack is written in Java, you could have a pause in the cluster for half an hour because it's doing Java garbage collection. So you could literally freeze your cluster for a half an hour while that Java machine is doing memory garbage collection. So these are the kinds of challenges. And stutter. I had the chance to go to a Linux Foundation conference in New York City at the New York Stock Exchange 3 years ago. And in fact, I went to talk about big data. But it was funny to see the guys from Wall Street and the traders and the financial companies. And you've got the most distinguished Linux kernel engineers up on a Q&A with Greg K.H. and Andrew Morton and Ted So and these guys who were the top of the Linux developer stack. And all those Wall Street guys, all they did was just pound the hell out of questioning the Linux kernel guys. Like, why can't you get this latency out of the kernel here and there? Stutter affects the same thing with Hadoop. So the emerging trends. Streaming, stuff that gets thrown off devices, and you need to capture it. You need to capture it quick because the value usually, I say usually, not always, but usually diminishes in value the slower you handle it. So sometimes you want it streamed, and the slower the data gets to you, the less value it has, in some cases. Fast data. Spark, you're going to hear a lot about Apache Spark, as I told you before. It's a very cool in-memory analytics tool that can do a lot of queries, and your experience with that. So what would you do with Spark?
So with Spark, what you end up doing is there are these modules for machine learning. So it takes a lot of the analytics work away from the data scientists and lets them program more to the questions and allows them to do it in memory. So if you want to do sentiment analysis, you don't need to build out your sentiment tree anymore, right? It's in Spark, and then all you need to do is process through that sentiment analysis engine. So it's a framework for being able to process fast data.
Yep. So we've heard a lot about SAP HANA. In fact, one of the customers is doing one of the coolest things. I want to get them to do a presentation with what they're doing with SAP HANA and SUSE is John Deere. They're smart tractors. The stuff that they're doing with that, with SAP HANA, is absolutely some of the coolest things. They use the tractors are smart, and they use that with sensors that are in the ground that understand the nutrients values, the moisture levels, and they add weather data, historic data, and things like that to optimally space the rows as the tractor plants the seeds in real time. That's using SAP HANA. That's just one thing that they're doing with it. Another customer that I've worked with is a truck manufacturer, and the whole idea of a smart truck, so that they can throw all that streaming data that's coming off these trucks in near real time to do predictive maintenance, to do predictive failure analysis and things like that. So they use not only the data coming off the trucks, but the historical data from their existing warranties, so that they can actually predict that, okay, this component's going to fail. And a flag would go off on the tablet of the driver's truck and say, you need to get to this service, you need this service thing done within so many miles or so many hours. That's one thing. Connectors are ubiquitous. So when I say connectors, what that means is that every major database vendor has a connector to talk to Hadoop, because you want to be able to take and extract stuff out of existing databases and make it talk to Hadoop, because it's also a cheap form of storage. The flip side also is file systems now can talk to Hadoop. So we have Ceph, and Ceph has a connector to speak Hadoop, and it can connect to Yarn. And so you can bypass some of the challenges of HDFS, the Hadoop file system, is that it's slow. And Ceph, because of the way it's written, can actually run faster. And it can work on all of the data that you have resident and live in your data center. We talked about Spark. Machine learning is becoming more and more accessible. One of the things that you can do, like, here's an example of what machine learning does, is like an outbound calling center can tape all the outbound messages and figure out, they can listen for the tapes, dump that data into Spark with machine learning, and then pull the words out that correlate with a sale or a no sale. So they can figure out how to make the pitch more effective. Despite lesser performance, and I always warn people, they think, oh, well, I'll just push that stuff into AWS and be done with it. I don't have to go buy a big platform of servers. No, very, very careful. True story at Cloudera. About the third week I was there, got a bunch of engineers, they all got their headsets on, they're all coding away. All of a sudden, the director of engineering comes in, takes a baseball bat, and he goes, bam, down on the table. And he said, everybody's like, what's going on? And he said, guys, stop what you're doing right now. I don't care what you're doing. Everybody get onto Amazon and shut down all of your running unused instances. We just spent $75,000 with Amazon last week. So we quickly ended up getting a nice big cluster of systems not long after that, because running big data in a cloud can actually be much more costly than running it on bare metal. The only way you can justify running big data workloads in a public cloud is if massive amounts of data are already there, because the upload costs are horrendous as well. And as I said before, Hadoop is rack aware. It's smart enough to know where the data is sitting. So some evaluation thoughts. Is big data a solution in search of a problem? Which is a valid question to ask. As I said before, evaluate real time versus near real time, because it's a big cost difference. Do we have the right questions to ask? That's what you said. How can big data workflows be integrated with our existing infrastructure? And that's another big part, is I've got this data. How do I now change my business processes to take advantage of the intelligence that I've gained? Really important step, and probably the most disruptive part of the step inside of a company. If you're in the government business, what other agencies might have useful data? And the companies that have successes run pilots, sometimes multiples. I work with a bank, a major top 10 bank. I worked with them a bit on their big data POCs, and they ran them for 8 months. And the reason being was they wanted a large enough POC from all of the big data vendors that they were talking to actually have more than a few days of playing with it. They wanted to really push the envelope to make sure that what they were going to finally end up with would really work. Again, piloting is super important. Don't just go buy a big system and say, oh, this is going to work. That's a big no-no.
Make sure the right people are in the room at the right time for the pilots.
Exactly. So let's talk a little bit about SUSE now. Why would SUSE care about big data? Well, number one, I always tell people SUSE has been doing big data before we had a name for it. Every Teradata system, every Teradata warehouse in the world since 2005 has been running SUSE Linux under the hood. A whole bunch of EMC systems as well. That's why we're the basis of SAP HANA. SAP runs its own business on SUSE. That's a pretty good endorsement. The other part is we have top tier support from Cloudera, Hortonworks, and MapR. We have reference architectures. They're certified. One of the things I did at Cloudera was make sure that the Cloudera Hadoop distribution would work on SUSE pretty flawlessly. What I found was I didn't have to fix anything. It just worked. And that's a really comforting situation to know that I could run SLES out, run my Cloudera system out, and it would just work. I have not seen, before I worked at SUSE or after, a bug filed related to big data on the SUSE kernel or SUSE technology. The other thing, let me go back. One of the other things, oh, no, it's in there, sorry. So, Big Top. I want to talk about Big Top, and that's how I'm involved in Apache. It's really nifty because it's a unique Apache project. We don't create anything except create a framework to import and ingest and create a stack with other Apache Hadoop components. And it's all the big distros base their product on Big Top, and it's a great place to experiment. You want to go build your own big data stack? It's there. You download the components, you kick off a build, installs. It has Puppet deployment scripts so that it can set up the cluster pretty much all magically, and it'll even launch containers for you if that's the direction you want to go. Why SUSE for big data? Well, that's an easy one for me. I could go a long, long time about this, but we have an enormously awesome story around HPC before we even had a word big data. 50% of the top 500 is SUSE Enterprise Linux. Titan, which is the biggest one, that runs on SLES. That's down at the Oak Ridge National Lab. That does nuclear bomb explosions, and it tests to make sure our nuclear weapons, by simulation, will still work. SUSE is the only kernel that can support 64 terabytes. Yes, 64 terabytes on a single system. Built by SGI, it's called a UV system. It runs at Pittsburgh Supercomputing Center. The only reason we can't go bigger is memory DIMM capacity. And the next generation memory DIMMs will allow us to go larger. We have an awesome optimized kernel for big data work. It's awesome because we've been doing this with SAP HANA and those supercomputing loads, which are very similar to what you would use with HANA, with Hadoop. We've got tier 1 support and relationship with all the major open source Hadoop distributors. Our competitor wrote a strategy paper and said, oh, well, here's the solution. We're going to create a connector to a Gluster, and sell you a Gluster. That's their big data strategy. It's a market we care about because we've had such a long, distinguished reputation in the HPC world. Michael, my colleague, has been in the HPC world. Gabby has. I mean, folks like us really understand that world so that when we go to talk to a customer in these very large environments, we have almost an innate understanding of the challenges they face. And that's just 3 of us, and there's 20-some, almost 30 of us in North America alone. Excellent deployment and management tools. We wrote a white paper. You've heard a ton of things about SUSE Manager. Probably you will if you haven't heard about SUSE Manager. We actually wrote a white paper to deploy Hadoop clusters with SUSE Manager, and it works awesomely. We care about this thing. And the deployment tools that SUSE writes, SUSE Manager has, are pretty awesome because they complement the existing cluster manager tools that come from the Hadoop distributors. So there's no conflict. So you have 2 windows to manage. One guy with 2 panes can manage an entire Hadoop cluster all by himself in real time.
Yeah, and if everybody was here for the keynote when Aaron was talking about SALT configuration, right? Start thinking of big data clusters. Let's say even it's a small big data cluster of 150 nodes, right? Try writing an SSH script, a for loop, to manage the configuration of a file and making sure that that's up to date constantly, right? Salt does that without even thinking about it. It's innate, right? That's the type of management that we're talking about, and the management tools and concepts for the big data.
Plus, like, not to cut you off, plus, like, for example, if you're in a regulated environment or a strictly regulated environment, you've got to be sure that you can go, your security and audit guys can, even in big data volumes, you can make sure that you can hand off a system that's up to date, that's you can audit easily, that's easy to patch, et cetera, et cetera. That's the power. That's the part where the cluster manager for the Hadoop distributions do not touch. They handle the cluster functionality for Hadoop and creating jobs and queries and analyzing performance of the cluster, things like that. But it doesn't touch the OS. So that's why the two really overlap really well. And we have a lab. We built a big data lab in Provo. And we use it for benchmarking, certification, integration test. We've written some reference architectures, and that white paper about deploying Hadoop with SUSE Manager. We have the demo system, and it's remotely accessible, which is nice. So we can do a pretty realistic demo to customers to show them, here's the dashboards. This is the experience of running a big data cluster. So we've got a website link. We can read the white papers, and big data at SUSE.com. That lands in my email box along with the business development manager. And there's some more resources. I will update the slides that are, either if they're not up there already, you will have this uploaded with all these links right after SUSECON closes. Questions?
Toward the beginning of the presentation, Peter, you had a massive, busy slide with all of these possibilities and all these packages you can use with big data. Is that because there just seems to be almost endless choice, that there's just so many components? Are there that many iterations and possibilities of big data and analytics when you're putting a system together?
I'm going to go back to that slide, because I can actually dive into that a little bit and explain something. Yeah, that's a good question. That's a really good question, Neil. So, for example,
I was talking about the previous one, not this one. The previous one.
Okay, so the previous one, these are just database vendors. So you look at MongoDB. This is caching. These are different kinds of caching things. Like you've got Granatia, and you've got Gemfire, which is from VMware, and you've got GridGain, which is Apache Ignite, and you've got IBM's got the stuff they call Extreme Scale, and Memcached and Infinispan, and these are all similar kinds of technologies. The thing is, it's a variance. Now the thing is, because of that, some of these have disappeared, and some new players are on the are in here. For example, Yark Data, which is close to DataStax, is actually owned by Cray, but now that's just kind of going away, and they're rebranding DataStax. So Cassandra and DataStax are fairly close to what Accumulo does, but they have different functionality, as I explained before. Cassandra's great for like sentiment analysis, shopping cart recommendations, and Accumulo is really awesome for security needs or for a lot of financial data, because it works really well with numbers in general. Think of Accumulo as Excel on steroids, that you can lock data, you can secure data down to the cell level. You can't do that with any of the others. Does that answer your question?
So these are just all the database components. And the next slide are the building blocks to make it all happen?
Yeah, so for example, well, if we look at the bottom, these are data sources and APIs for data sources. So over here, This is all kinds of healthcare stuff. You've got Jawbone, you've got Fitbit, you've got Apple watches. So that's a data source. And then you got IoT things. You got Uptake and some other vendors. And then financial and economic data. You got stuff that you can grab from air and space. You got location data. It comes from Garmin. It comes from Experian, who has a really nice story about Esri, Inside View, Factual, Place IQ. And that's not all of them. Foursquare. That's all location data. And then you look over on the right, incubators and schools. All of these places are just data sources and APIs. So if you look at frameworks, you've got Hadoop. You have Mesos, which is an orchestrator. You have query and data flow. So you have Hive and Apache Drill, two things that do something similar. Drill came from Google because they didn't like Hive. So sometimes some of these DBs and some of these projects come about because a big company like a Google will look at a technology and say, well, this is great, but this has got some architectural deficiencies, so we'll create our own. So that's where a thing like Apache Drill comes from. And then you've got different coordination frameworks. So you've got Talend, which is open source, but then you've also got something called Zookeeper. I always joke about the Apache ecosystem. It's usually named after some little animals, and it's actually orchestrated by something called Zookeeper, and that's for real. So that kind of gives you an idea of infrastructure. And then you've got the infrastructure that you need to run it on, and then you've got different kinds of storage. You've got security. You've got monitoring, graph databases, cloud enterprise data warehouses. You've got transformation. So you see Alteryx, Talend, Trifacta, they're all on that same kind of end of the world. They don't even have, they're missing sync sort. So that gives you the kind of the challenges in terms of picking the vendors.
But also to elaborate on that a little bit and delve a little deeper into your question, the slide before slots into, if you go back, slots into, and go to the next one. So this slide slots into various components into here.
Yes.
So the real-time, the data access at the bottom center, the NoSQL and the NewSQL databases, right? Those are just the components. The other pieces are more about management and infrastructure and analytics and getting to the question, what tool do I need to answer my question? And who's going to be better at answering my question for me?
Yep. Like, for example, if you look in the analytics section here, you've got real-time, you've got machine learning, you've got search. You have horizontal AI, as we call it, and then you've got social analytics, you've got log analytics, like Splunk and Kibana, and then you have visualization tools to take all that data in numeric form and actually post it in graphs and things like that. So that's why the complexity is there, because these actually all do very separate jobs in your big data solution.
Yeah, I call this the great slide of consolidation for 2018.
Yeah, that's a good way to put it. And I want to go down to finish after. I want to show you this because this is an appendix, and I'm not going to walk you through it, but I want you to be aware that it's there because this shows you the distribution, how it works, what it does, what these components do, and then you'll see the cute little animals as I keep going. And Uzi and Flume and Mahout and all that about how these components like Giraffe and Apache Pig and Ambari and Hue and Spark is all organized by Zookeeper. And I didn't even mention Squirrel or Hawk. So yeah, that is there for you as a reference to look at later on with a bunch more links there. So I wanted you to be aware of that I added that as an appendix just for study at home. Thanks very much.